doing is we're going to be making a video on how to determine if a blood transfusion will be successful or not. Now, this is really important, especially in the health field, because if you have a patient that is bleeding out or does not have the or is losing a lot of blood, we want to be able to deliver the right type of blood. Okay. This is crucial because if we do not give a compatible blood transfusion to the recipient or to the patient, that can cause some significant health issues on top of whatever they're dealing with, and those health issues can be lethal in some scenarios. Okay. And so what we're going to be doing today is we're going to be looking at how we're able to perform, or how we're able to make sure that a blood transfusion will be successful. Okay. So there's a few steps to this, and so let's go ahead and give a scenario here. Let's say we're dealing with a recipient who has B negative blood. Okay. And then we're going to look at a donor, and we'll say the donor is going to be someone who is A positive. Okay. So the recipient is going to be the individual receiving the blood. The donor is going to be the one donating the blood. Okay. So this can be a little confusing to learn at first, but there's a few steps that you can do to help you try to identify whether this will be a transfusion that will work effectively or not. Okay. And so the first step to do this, when you're first learning this, is to draw out the red blood cells. Okay. Draw out the red blood cells for both the recipient and the donor. Okay. So I'll write that on the side. So draw red blood cells for both individuals. Okay. Individuals. Okay. So if we're looking at the recipient has B negative. Test. Testing, 1, 2, testing, 1, 2, testing. Testing, 1, 2, testing, 1, 2. Okay. All right. Okay, so for today, what we're going to be doing is a quick video on how to perform, or how to determine whether blood transfusions will be successful or not. And so when you're first learning this, this can be a little bit tricky, but I've got a few steps that will help you figure out exactly whether that transfusion will be successful or not. So this is going to be really important because if we have a patient that happens to be bleeding out or is losing large amounts of blood, we need to be able to give them blood, but not just any blood. They need to get the appropriate blood type, because if they get a blood transfusion that is not compatible with their own blood, they're going to end up rejecting that blood, and that can cause some significant health issues in the recipient that can possibly even be lethal. Okay. So I'm going to show you a few step-by-step ways to kind of figure out how to go about this, and we'll do a few examples over the course of this video. Okay. So we're going to start with the recipient, and we'll say the recipient has B negative blood. Okay. And then we're going to work with a donor, and the donor is going to have a positive blood. Okay. So the recipient is going to be the person receiving the blood, the donor is going to be the person giving the blood. Okay. So the first step to doing this is to determine is to draw out the red blood cells. Okay. So I'm going to write that on the side here. So draw the red blood cells. And you want to draw the red blood cells for both individuals, both the recipient and the donor. Okay. So if we draw out the recipient's blood cells, okay, we're going to see B antigens, okay, which are the proteins on the red blood cell. Okay. And because we have a negative, they are not going to have the Rh antigen. Okay. So they're going to have just the B antigen and nothing else. Okay. When we look at the donor is going to have the A antigen because they're A positive. Okay. And because they have this positive here, that's going to indicate that they have the Rh antigen as well. Okay. So I'll go ahead and draw that here. Okay. So there's the Rh antigen. Okay. So that's the first step. The second step is to determine the antibodies that the recipient will be producing. Okay. So I'll write that here. So determine recipient's antibodies. Okay. So remember, you're going to be producing antibodies against whatever blood type you do not have in your own body. And that's going to be important because that's going to help your body be able to fight off foreign pathogens or foreign things that enter your body. So when we're dealing with a person who has B negative blood, okay, they're going to be producing antibodies against whatever they don't have. Okay. So they don't have an A antigen, so they will be carrying the anti-A antibodies inside their blood plasma. And they do not have the Rh antigen, so we know we're going to be producing the anti-Rh antibodies as well. So that's going to be crucial because if this person's blood comes into contact with any type A blood, it's going to recognize that as foreign and say, hey, this shouldn't be here. We need to get rid of this. And same with the case for an Rh antigen. Okay. So we've drawn out our blood types, or our blood cells. We've determined the recipient's antibodies. The next thing that we need to do is we need to determine if the donor has anything that the recipient's antibodies are going to fight off against or reject. Okay. So we want to determine if the donor carries antigens that will be rejected. Okay, so that's the third and final step. So if we're looking at the recipient is going to have anti-A antibodies. So they're going to be fighting off against any A antigen. Okay. So in this case, we look at our donor, and we see that the donor does have A antigens. So we know the anti-A antibodies are going to fight off against the A antigens on this blood. So that's going to be rejected there. Okay. We also see that the recipient will also carry anti-Rh antibodies as well. Okay. And we see our donor also carries the Rh antigen. So if we try to perform this transfusion here, this would not be successful because, use a different color, the anti-A antibodies are going to fight off against the A antigen, and the anti-Rh antigens, or antibodies, are going to fight off against the Rh antigen. So this would not be a successful transfusion. This would not work at all. Okay, that would be an unsuccessful transfusion, an incompatible transfusion. Okay, so we don't want to be doing that. Okay. Let's change up the scenario, and let's say we are now working with someone who is a donor, and let's say this individual is B negative. So I'll kind of draw that here. I'll erase all this. Okay. Let's say our donor is, instead of being A positive, is B negative. Okay. Again, we're going to go through this whole process exactly the same way. Okay. We're going to draw out the red blood cells. So we're going to see they're going to have the B antigen on the red blood cells, but they will not carry the RH antigen because, again, they're negative. Okay. So we draw out the red blood cells. We determined the recipient's antibodies, anti-A and anti-RH. And the next thing that we're going to do is we're going to determine if the donor has anything that the recipient will reject. Okay. So the recipient has anti-A antibodies, but here we don't see any A antigen on your donor, or your donor red blood cells. So we know that one is going to be okay. Okay. The next thing we do is we're going to look for the anti-RH antibodies. Anti-RH antibodies are going to fight off against the RH antigen. Okay. And so, again, we look for the RH antigen on your donor, and we don't see any RH antigen. So we know that the anti-A antibodies are not going to be activated. The anti-RH antibodies are not going to be activated. And so as a result, we know that this will be a transfusion that works. Okay. This is a happy transfusion. This is a good one that will help to benefit our patient or our recipient here. Okay. Let's change up the scenario ever so slightly. Okay. And let's say instead of having a patient or a donor who is B negative, let's say they are B positive. Okay. So again, we're going to draw out the red blood cells. Okay. So we know here we have the B antigen here. We have this positive, so that's going to indicate we also carry the RH antigen. Okay. And then we're going to determine our antibodies. We have the anti-A and anti-RH antibodies here. Okay. And now we're going to look for any antigens on the donor red blood cells that are going to be rejected by the recipient. Okay. So we look for the anti-A first. So A antibodies. We don't see any A antigen on our donor, so we know that one's okay. However, we also have anti-RH antibodies. Okay. And as we see in the donor, we also carry we also carry the RH antigen here. Okay. And so this would be a transfusion that gets rejected because we see the RH antigen. Okay. So even though we're still dealing with type B blood and type B blood, okay, this rejection still, or this transfusion will still be rejected because the donor carries the RH antigen. Okay. So you cannot simply use, the letter to help you determine whether a blood transfusion will be effective. You also have to consider, okay, the RH antigen as well. Okay. And so this would not be a transfusion that is effective. Okay. So B negative would work, okay, but B positive would not work. Okay. And so that's kind of going to be a trend. So if you're looking with, if we kind of go back to having a patient that has B negative, okay, this is a trend that we're going to see as a pretty common trend. So if you are, whatever blood type you are, okay, you're also going to be able to accept that particular blood type. Okay. So if you're B negative blood, okay, if your blood type is B negative, you're always going to be able to accept B negative blood. If your blood type is A positive, you're always going to be able to accept A positive blood. If you're O positive, you're always going to be able to accept O positive blood. Okay. So whatever blood type you are, you will always be able to receive that particular blood type, okay, as well as a couple, maybe one or two others, depending on the scenario. Okay. Okay. So that is that. Let's also do another example here. And let's say instead of dealing with B negative blood, we are going to deal with someone who has AB, we'll say AB negative blood. Okay. So because we have AB negative blood, the first thing, again, we're going to do is we're going to draw out our red blood cells. Okay. So here we have the A and B. So we're both going to have the A antigen and the B antigen. Okay. So we have the A antigen and the B antigen, okay, but no RH antigen here. Okay. So again, you determine your antibody types, and then you're going to use the antibodies to determine if there's going to be a rejection here. Okay. And what we see is that we are going to have anti-A antibodies that are going to be fighting off against this A antigen here. Okay, so that's going to be a problem. And so as a result, this rejection or this transfusion would be rejected. Okay? All it takes is one antibody to fight, or one antibody to be activated to cause a rejection altogether. Let's do one other one, and let's say we're looking at someone who is we'll say O negative. So we're going to deal with someone who has O negative blood. And so someone who has O negative blood does not have the A antigen, okay, and they do not have the B antigen. Okay. They also carry this negative, which means they do not have the Rh antigen. So their red blood cells are essentially naked. And so when we look at so we've drawn out our red blood cells, and we're also going to take a look at the recipient's antibodies. We see anti-A antibodies. Okay? But if we look at the donor does not have any A antigens on it. Okay? We also see anti-Rh antibodies in the recipient as well. But again, we don't see any Rh antigens on the donor. Okay? And so because none of these antibodies are going to be activated, okay, this would be a transfusion that is successful. Okay? This is a happy transfusion. Okay? And so for this reason, we call O negative blood, or people who are O negative, as the universal donors. Okay? And the reason for that is because they will always carry, they never carry any antigens. So there's nothing for anybody's body or anybody's antibodies to react to on the donor blood. Okay? So O negative is the universal donor. Okay. All right, so that's that. Let's do another few examples. So let's say our recipient now, I'm gonna kind of erase all this here. Okay, so now we're gonna say our donor has, instead of B negative blood, let's say they have AB positive blood. Okay. And let's say that's in the recipient. The recipient has AB positive blood. Okay. Let's say our donor has, we'll go with A positive blood again. Actually, we'll go with B positive. We'll change it up a little bit. Okay. We'll say B positive. Okay. So again, the first step that we're going to do is we're going to draw out our red blood cells. Okay. So if we're looking at the recipient, okay, he's going to have a red blood cell. He's going to have the A antigen, because that's who we see here. It's also going to have the B antigen, okay, also over here. And then we're also going to carry the Rh antigen. Okay. Then we're going to look at our donor. So our donor has B positive blood, so they're going to carry the B antigen. And they're also going to carry the Rh antigen. So we've drawn out our red blood cells. Okay. The next thing that we want to do is we want to determine any antibodies that a recipient is going to have. Okay, remember, the antibodies are going to be against anything that the red blood cell does not have. Okay. So the recipient has the A antibody, the A antigen. Okay, so it's not going to be producing any anti-A antibody. It has the B antigen. Okay, so it's not going to be producing the anti-B antibody. Okay. And it's not going, and it has the Rh antigen, so it's not going to be producing any anti-Rh antibodies. Okay, so remember, you're going to be producing antibodies against whatever you don't have. If these guys have everything, and so it would not be advantageous for this individual to have anti-A antibodies, because if they had anti-A antibodies, they would be fighting off against their own red blood cells. Okay? Same thing with the anti-B antibodies and the anti-Rh antibodies. Okay? So AB positive carries no antibodies. Okay? So we'll just kind of leave that blank, no antibodies there. Okay? And so for that reason, well, I'll just kind of write that down here. No, I'll put ABs, no, let me just write it out. So no antibodies. No antibodies. Okay? So they're not going to have a rejection or a reaction against any other type of blood. So if we try to give B positive blood, this transfusion would be successful because AB positive individuals do not carry any antibodies. So
there's not going to be anything to cause a reaction or an immune reaction. Okay? Same thing if we did AB negative blood. Okay, if we give AB negative blood here, we draw our red blood cells, we're going to have A, we're going to have B, and then no RH. If we try to give it to AB positive, again, the AB positive individual does not carry any antibodies against any type of blood. Okay? So this transfusion would be successful as well. Okay? So any type of blood that you give to an AB positive individual, okay, that is going to be a successful transfusion. Okay? And so for that reason, we call the AB positive individuals the universal recipients, because they're capable of receiving any blood type. Okay? They're capable of receiving any blood type because they do not produce any antibodies that will fight off against any type of blood, okay? Or any kind of blood. Okay? So that is AB positive. Okay? Now again, let's change this scenario slightly here. I'll kind of just erase all of this here. And let's say, so AB positive are the universal recipients. We're going to change this scenario just a little bit here. And let's say that our recipient, instead of being AB positive, is AB negative. Okay. So again, what we're going to do is we're going to draw out our red blood cells. And we're going to see that they're going to have the A antigen. We're going to have the B antigen. Okay. But they do not have the RH antigen because they're negative. Okay. So, and then we see still with our B positive blood on this side, okay, with the donor. Okay. Now, if we take a look at the antibodies that they're going to be producing, okay, the recipient will not be producing any anti-A antibodies because, again, they have that on their own red blood cells. Okay. They're not going to have any anti-B antibodies because, again, they have that on their own red blood cells as well. Okay. But they will be producing anti-RH antibodies, okay, because they do not carry that on their red blood cells. So we're going to see anti-RH antibodies. I'll just put anti-RH. So if we try to give this person B positive blood, okay, the only antibody we need to be concerned about is whether they have the anti-RH antibodies. So these guys have the anti-RH antibodies, so we're going to be looking for the RH antigen on the donor. Okay. So the donor contains the RH antigen, and so this would not be a successful transfusion. Okay. Now let's say we want to switch things up to look at an individual who is we'll say O positive. Okay. So let's say they're O positive. If they're O positive, they are not going to contain the A antibody. Okay. They're not going to contain the B antibody, okay, but they will contain the RH antibody as well. Or sorry, the antigens. Okay. Okay. So again, the recipient will only carry the anti-RH antibody, and so we're going to be looking for the RH antigen on this donor blood. Okay. We see the RH antigen here, so if we try to make this transfusion work with O positive blood, that would also be an incompatible transfusion. Okay. Now, if we made this O negative instead, let's say, I'll just kind of erase this and I'll say if this was O negative, okay, we have no A antigen, no B antigen, and no RH antigen. Okay, so I'm going to erase this guy here. Okay, so if we try to make this transfusion work, okay, again, we're looking for the anti-RH antigen on the O negative blood. Okay, we don't see it, and so we know this would be a compatible transfusion. Okay. Yeah, so that's the case there. And so that would be a scenario that's going to be that you may see as well. Okay. A third scenario is if you tried to give this person AB negative blood. I'll erase this over here. So let's say we wanted to give AB negative blood. Well, actually, let me just erase this whole thing. Okay. So we'll look at both AB negative and AB positive scenarios. Okay. So we're looking at AB positive. Again, we draw out our red blood cells. We're going to have the A antigen. We're going to have the B antigen. And we're going to have the RH antigen. Okay. So again, looking at the recipient is only producing the anti-RH antibody. Okay. So again, you're going to take a look at the donor and see if we see any of the any RH antigen. We see that here, and so this would be a transfusion that is rejected. Okay. If we switch over to AB negative, erase this here. Again, drawing on our red blood cell, we're going to have the A antigen. We're going to have the B antigen, okay, but we will not have the RH antigen because we're negative. Okay. We look to see if the recipient will produce any antibodies against anything that the donor has. We don't see any RH antigen, so we know this would be a successful transfusion. Okay, so that's that. We're going to give one more example here. Or a couple other sets of examples. So I'm going to kind of change this whole scenario here. And so let's say we're dealing with a recipient who has, we'll say they have O positive blood. Okay. So, and then let's say we're dealing with a donor who has AB positive blood as well. Okay. So donor has, or sorry, the recipient has O positive, the donor has AB positive. Okay. Again, what we're going to be doing here is the first thing we're going to be doing is drawing out our red blood cells. Okay. So with the recipient, we are not going to have the A antigen, okay, because we're O positive or O. Okay. We're not going to have the B antigen, but we will have the RH antigen, okay, which we see right there. Okay. So there's our RH antigen. Look at our donor. The donor is going to be AB positive, so we're going to see the A antigen. We're going to see the B antigen, and then we're also going to see the RH antigen. Okay. So now what we're going to do is we're going to draw out or determine the recipient's antibodies. Okay. And so the recipient is going to produce antibodies against whatever it does not have. Okay. So it does not have the A antigen, so it will have the anti-A antibodies. Okay. It does not have the B antigen on the red blood cells. So again, it will have the anti-B antibodies. But it does have the RH antigen. So we will not have any anti-RH antibodies. Okay. Okay. So the third thing that we're going to be doing is we're going to be looking to see if the donor contains any antigens that the recipient will reject. Okay. So the recipient has anti-A antibodies. Do we see A antigen here in the donor? Yes, we do. So we know that's going to be rejected right off the bat right there. Okay. We also see that it carries anti-B antibodies. Okay. And so we're going to see a rejection happening over there as well. Okay. So this would not be, if we try to do this transfusion, this would not be a successful transfusion. Okay. And so for that reason, anytime you're dealing with an individual who is either O positive or O negative, they can only receive type O blood. Okay. The reason for that is because they're going to have the A antibody. So if you give them type A blood, okay, they're going to fight it off. Okay. If you try to give a person who has type O blood type, and you try to give them type B blood, okay, they're going to have the anti-B antibody, so they're going to reject that. Okay. If you give them AB positive or AB negative, they're going to have both, and so again, you're going to have kind of double the rejection there. Okay. So anyone who is type O blood can only receive other type O blood. Okay. So again, we'll kind of give a couple other examples. So I'm going to erase this here. And let's say we are dealing with an individual or a donor who is O negative. Okay. If the donor is O negative, okay, again, their red blood cells are going to be naked. Okay, they do not have the A antigen. Okay, they do not have the B antigen. Okay, and as we see this negative, they're not going to contain the Rh antigen. Okay. So now we take a look at our, so we have a naked red blood cell with no antigens on it. Okay. So now we're going to be taking a look to see if the recipient has any antibodies that are going to fight off against anything that the donor has. Okay. As we see with this donor, okay, we don't have any A antigen, okay, so we're not going to have a rejection there. We don't have any B antigen, so we're not going to have a rejection there. Okay. All of our antibodies are accounted for. Everything is hunky-dory. We're all good to go. This would be a successful transfusion. You have a nice little happy face there. Okay. So type O individuals can only receive type O blood. So if you're O positive, you can receive both O positive blood as well as O negative blood. Okay. Now let me change this scenario just a little bit here. And let's say instead of dealing with someone, a recipient who's O positive, we'll say the recipient is O negative. Okay. And we'll say the donor is O positive. So we'll switch this whole scenario around here. Okay. All right, so looking at our recipient, and we're going to draw out their red blood cell. Okay, again, no A antigen, okay, no B antigen, and because we're negative, we have no Rh antigen. Okay. We look at the donor. Okay, donor has no A antigen, no B antigen, okay, but they do have the Rh antigen. Okay. So now we're going to take a look at the antibodies that are going to be produced by our recipient. Okay. The recipient does not have any A antibody or antigens, so it will have the anti-A antibodies, or anti-A. Okay. They do not have the B antigen, so they will have the anti-B antibodies. Okay. And they do not have the Rh antigen. Okay. So they will have the anti-Rh antibodies as well. Anti-Rh antibodies. Okay. And so now our last step is going to be to determine if the donor has anything that the recipient will reject. Okay. We don't see any A antibodies, or we see A antibodies in the recipient, but no A antigen in the donor, so we're good there. Okay. We see anti-B antibodies, but no B antigen in the donor, so we're good over there. However, we do see anti-Rh antibodies, okay? And we have the Rh antigen in the donor. Okay, so if we try to make this rejection work, or sorry, this transfusion work, we would see a rejection because the anti-Rh antibodies are going to be fighting off against the Rh antigen on your donor. Okay. So this would not be a successful rejection, or a successful transfusion. This would be rejected here. Okay. So for people who are O negative, they can only receive O negative blood. Okay. So again, I'm gonna kind of draw out another O. Let's say this is O negative. Okay. Again, no A antigen, no B antigen, no Rh antigen. Okay. They're only going to be able to receive O negative blood because they have the A, B, and Rh antibodies. Okay. O negative blood does not have A, B, or Rh. Okay. So any individual that is that has type A, type B, or type AB will immediately be rejected by someone who is type O. Okay. And then because this individual is negative, they're going to be producing Rh antigens or antibodies. Okay. And so they cannot receive any positive blood. Okay. So A positive, B positive, AB positive, or even O positive are not going to work because they're going to be carrying the Rh antigen that will eventually be rejected by the anti-Rh antibodies in the recipient. Okay. So these are just a few different practice problems to kind of help you identify whether these transfusions will be successful or not. Get a little bit of practice with this. I hope this makes it a little bit more clear. And so this will be something that you will see on the exam as well as on the homework going forward too. So make sure that you feel comfortable with identifying successful transfusions. Again, the steps to kind of go through this would be to, number one, draw out the red blood cells for each individual, both the donor and the recipient. Okay. To determine what antibodies the recipient is going to be producing, and not the donor, because that's not going to be helpful for your scenario. Okay. Just the recipient. And then number three, determine if the donor's blood will carry any antigens that will be rejected by the recipient's antibodies. Okay. So hope that makes sense. If you have, if not, go ahead and feel free to email me over the weekend, and I can try to make this a little bit more clear for you. Okay. So that's that. If you guys have any questions, feel free to get in touch. Otherwise,